All right, let's go ahead and get started. Good afternoon. Welcome to Exchange Server High Availability and Site Resilience. A couple of housekeeping notes. Like all the other sessions, this one is being recorded. So if you could, please silence your mobile devices. That will be most appreciated by the recording and your neighbors. Also, in case you're not aware, both the recording and these slides will be made available for download on Channel 9 after the event is over as well. So all of the information that you've seen, you'll be able to collect the slides and use them for your own purposes as well. All right, for those of you who don't know me, my name is Scott Schnall. I'm a Senior Program Manager on the Office 365 Customer Experience team. That's a role in which I work with Office 365 customers or potential customers in moving to the cloud by helping address any of the concerns they have around risk and compliance and trust and privacy and so forth. But today we're here to talk about Exchange High Availability and Site Resilience. So let's see who's in the room. How many of you are running 2013? All right, 2010? Okay, 2007? Anybody want to admit to anything earlier? No? Just a couple, wow. I wouldn't admit to that, yeah. Okay, so what I have for you today is we're going to do a brief recap of the high availability and site resilience features. It's just a quick brief overview so everybody has a level set in case you're not familiar with all the goodness that we have in 2013 and very soon 2016. And then we'll get into the best practices around DAG configuration, site resilience, cluster settings, quorum, witness, networks, et cetera, et cetera. All right, so let's just start with a brief recap. This may be an overview or refresher for those of you, especially if you're responsible for managing a DAG or designing DAGs. But just so everyone is familiar with the functionality in Exchange, Exchange can now recover in 2013 and 2016 from basically any failure. A database level, a server level, a network level, even an entire data center. Exchange can automatically recover both data access and service access. We've made some fairly significant improvements in this space for Exchange 2016. So as an example, failover is about 33% faster in 2016 than it is in 2013. And for those of you keeping track, 2013 was already 50% faster than 2010. So things are getting faster and faster and faster. Even though databases are growing larger and larger, we're still able to flip that bit and activate somewhere else very, very quickly. We also have a reduction in IOPS in Exchange 2016, but the way in which we got it is kind of tricky, and I'll explain later on. But there is, in fact, a real reduction in IOPS for users hitting an active database of about 33% over Exchange 2013. And then reseeding. Obviously, the preferred architecture that we have has you deploying on JBOD. JBOD is just a bunch of disks. There's no RAID. So when a disk fails, it takes out the database or databases that are on it. So you'll need to reseed periodically, and reseeds are about 58% faster in 2013 and 2016 than they were in 2010 due to a configuration called multiple databases per volume, which hopefully all of you are using because that's also part of the preferred architecture. So fairly significant improvements no matter what platform you're coming from with the DAG. So what do we mean when we say high availability and site resilience? Obviously, for the mailbox, it's taking the DAG, the database availability group, and using that as the construct to replicate copies of databases to other servers and hopefully other locations for site resilience as well. For the transport aspect, the way to think about Exchange high availability for transport is that it will make a copy of every single message both before and after it's delivered. And if your DAG is extended to multiple sites, it will do that in both sites for you automatically. Again, all that happens transparently through features like shadow redundancy and safety net. And then the client access high availability, well, that's just achieved through a redundant set of stateless servers that have intelligent proxy capabilities and sit behind a bunch of load balancers. It's a pretty simple story there for the client access front end. Now, our preferred architecture, I went over that in detail yesterday. Hopefully, you got a chance to see that session. If not, again, it's recorded, and the slides are available to you. But basically, the preferred architecture is all about high availability, and if you have multiple locations, all about site resilience as well. Okay, and it means that you are creating a DAG with at least 4 database copies, 2 in each data center, and you're replicating that traffic over a single network card in each DAG member. You're using an unbound single namespace like mail.contoso.com, so that's all your users have, no matter where they are anywhere in the world, internal or external. Preferably, you're using layer 7 load balancing without session affinity so that you can get per protocol availability instead of per server availability if you use something like layer 4 with a single namespace. In the case of Exchange 2013, we want you to deploy multi-role servers, so CAS and Mailbox on the same box. In the case of Exchange 2016, we took that option away from you. There's just one role, the Mailbox role, and that includes everything. So every server in 2016 is a multi-role server. You have no choice. You deploy everything. Even if you're not using you're getting all the bits. You don't have a choice anymore. The witness, we'll talk a little bit more about witness placement, but the preferred architecture has that in a third location. Without a third location, you don't get automatic failover in response to a site-level event. You'll have to manually do what we call a data center switchover, which is still a viable thing to do. But these days, now that we support things like Azure for deployment of your witness, now you have the ability economically to achieve that automatic site failover. Talk about Azure in a little bit as well. 4 copies, one of those copies with a 7-day lag with our automatic playdown feature engaged as well. And we made some changes there, and that's where we got our reduction of IOPS, and I'll talk about that in a minute. And then multiple databases per volume, so on that one disk, on that one single 7,500 RPM SAS disk that is not protected by RAID, we want you to put more than one database on there. We want you to put 4 databases ideally, 1 active, 2 passives, and 1 lag copy. Again, that's the preferred architecture. And then finally, you're using Exchange native protection. So you've got things like single item recovery, maybe in-place hold, like the lag copy, and of course the activation features of the DAG that provide you with enough redundancy and resiliency where you no longer need to take traditional backups. So before I move on, does anybody have any questions about the recommendations around the preferred architecture? Yes? Why what? Why a 7-day lag? To give you enough time to respond to, so the question was why a 7-day lag? To give you enough time to respond to anything that might happen. So if something happens over a weekend, you might not pick it up till Monday. That's 2 days right there. We want to give you enough time to go back into a point of time before whatever incident happened. All right, any other questions? All right, fantastic. Now, let's talk a little bit about site resilience. Site resilience has been significantly improved in 2013, such that 2013 and, of course, 2016 give you the ability to have what we call a data center failover. There's a difference in terminology there. A switchover, that's a manual administrative task. Failover is something that happens automatically by the system. In 2010, the data center failover did not exist. 2010 was not designed for it. 2013 and 16, on the other hand, were. We specifically made architectural changes starting in 2013 in order to support them. One of those changes was things like the introduction of MAPI over HTTP and turning Outlook itself into a raw HTTP client. And this then means that most client access for Exchange is now HTTP based. And that gives us some behavior, some actually behavior that's been in there a while, that allows us to exploit. Okay? All HTTP clients, whether it's in a browser, an operating system, or just an HTTP stack, easily all modern clients, and by modern I mean something that's been existing for maybe 10 years or more, all those modern clients have built-in failover capabilities for themselves. Okay? And so what that means is from a failover standpoint, you don't have to mess with DNS anymore. You could do something like take one namespace like msdn.com and assign it multiple IP addresses. And when the browser does its DNS lookup, it gets all of those IP addresses, usually in a random order because the server is randomizing how it sends it out, and it stores it in its cache. So if one of those IP addresses isn't available, it will wait approximately 20 seconds and then try the next IP address in its list. And so this way, with a single namespace and multiple IP addresses, you give the client itself this failover behavior. And you've been experiencing this on the internet for a while now. You go and do an NS lookup about any domain name, and you'll get a bunch of IP addresses, at least 2 for every one. And if you have IPv6 enabled, which most of you probably do, you'll also get some IPv6 addresses as well. And that's the whole point on the internet, is we're giving you multiple endpoints for the browser to try. And that's something that we're exploiting here, so that when you have a DNS failover, or excuse me, a data center failover, the browser already has the DNS addresses that it needs. It doesn't have to change names. You don't have to mess with DNS. You could, if you wanted to, go into DNS and take the failed data center's IP address out of rotation, but it's still only going to cost about 20 seconds in terms of failover. So it really depends on how long the outage is going to be if you want to do something like that. But by exploiting this behavior, now admins can see failover or switchover happening very quickly instead of maybe hours like you might be experiencing in 2010. All right, and then the lag copy enhancement. That's something that we introduced in 2013 through the Dynamic Replay Lag Manager, and we've enhanced it in 2016. So starting in 2013, we gave lag copies basically the ability to care for themselves. By default, if within a 24-hour period there are not 3 other healthy copies of a database, a lag copy in 2013 will automatically play itself down. And by that, I mean it'll start playing its log files and bringing itself more and more up to date. That's one condition where it will do it. It will do it also if it detects corruption that needs to be page patched. Page patching is something we introduced in 2010 to fix a bad page in a database by getting a good page from one of its replicas. But in 2010, we couldn't page patch a lag copy because the lag copy might not be at the point where the database includes that page yet. But now, in 2013 and 2016, we'll bring that database forward to automatically patch it and make it good. And then the last thing is if there's some capacity concerns. So say, for instance, one of the databases is running out of disk space on the database or log volume. When that happens, that will forcibly dismount that database, but it will also cause the buildup of logs on the other database copies because of the laws of log truncation. So now if we detect that there's a capacity concern, again, that lag copy will be played up to date and turned into what we call a healthy, viable, or a highly available passive copy. One of the things that we changed in 2016 is we noticed that in 2013, for customers who deployed our preferred architecture that had multiple copies per volume, multiple databases per volume configured, was that when we were doing this dynamic log replay of the lag copy, it was affecting the user activity for the active copy that was also in that volume. So we made a change. We introduced some new I/O monitors inside of 2016, and now they monitor disk latency. And if we see disk latency go beyond 20 milliseconds, we'll delay the log playdown. And presumably that's due to user activity. Once we see that the disk space is below the 20 millisecond threshold, we'll start the log playdown again and keep things going. The only time that we won't delay is if there are some sort of capacity concerns where something is about to run out of disk space, and then we'll start playing logs forward so they can be truncated. All right. So now let's talk a little bit about best practices. How many of you are responsible for operating a DAG today in any version of Exchange? All right, many of you, great. So hopefully, as we talk about these configuration settings, hopefully all of you are set correctly, or you at least understand what they are and how they can affect your DAG and what they mean. So let's start with the cluster settings, and let's start with a big one that's sort of in flux right now, as we're in the process of removing it that we began in 2013. And this is a cluster administrative access point, or the admin endpoint to which you can use the failover cluster management tool to connect to and manage a cluster. This is something that has just been a part of clustering that Exchange has dealt with, but Exchange actually has no need for and doesn't use. Now, there is some third-party use of it, which I'll talk about in a minute. But basically, when you create a DAG, you're giving it many properties. A couple of those properties include things like a name and an IP address, okay, or maybe multiple IP addresses if it's a multi-subnet DAG. Okay, those properties then translate into the same corresponding properties for the DAG's underlying cluster. So the name you give the DAG becomes the name for the cluster. The IP addresses you assign to the DAG becomes the IP addresses assigned to the cluster. And they were only used by the cluster and then occasionally by third-party applications that were exploiting this named endpoint resource that was addressable over IP. Exchange never used these artifacts, but they still existed. In fact, if you were to run get cluster resource, this is typically what you would see on a DAG that has a cluster admin access point. There are several resources there. Some are IPv6 because IPv6 is enabled. Some are IPv4 IP addresses. And then there's also the DAG name and the file share witness as well. Okay, now all of those things, except for the file share witness on the bottom, are resources that Exchange doesn't use and doesn't care about. But from a monitoring perspective, those things are things that will generate and cause alerts when they go into an offline or failed state. And if you can imagine the number of DAGs that we have running inside of something like Office 365, and the number of alerts something like this might generate as a result of these network addresses going on and offline, or network names failing because of name resolution or router misconfiguration or whatever. And of course, any alert that is happening on a DAG has to go to the Exchange Data Center Operations team. And as you might imagine, getting alerts about things that we don't need or don't care about, after a while gets kind of annoying. So the Windows team in Windows Server 2012 came up with the ability to create a cluster without an administrative access point. This is different from creating an Active Directory disconnected cluster. That's a different setting altogether. Very similar setting, but it uses the same parameter, but a different property value. So this is not the DNS-only cluster. This is not the Active Directory disconnected cluster. This is a cluster without an admin access point. So no IP addresses and no cluster name. And because those things don't exist, the actual cluster itself as a networked object also doesn't exist. So there's no computer object for the cluster. There's no IP address. You can't address it over the network. It's not reachable. You also can't manage it with the failover cluster management tool. You can only manage it using PowerShell and by using these specific computer names that are members of the cluster instead of the cluster name, because the cluster name doesn't exist. All right, now, on the previous slide, let's go back to that. That will be the default configuration for DAGs when you create a DAG using PowerShell in Exchange 2016. You can do this today in 2013. This is when we introduced it. But be aware, again, there are third-party applications, most likely backup applications, that sometimes will connect directly to the cluster name and IP address. So we still give you the ability to create those old constructs if you need them. But our advice would be to get an application that doesn't require them, because you don't want them in your DAG. Or better yet, if it's a backup application, stop using it altogether and just use native data protection instead. All right. So even though you're creating a DAG potentially without an admin access point, underneath it obviously is still a viable cluster. And there still is cluster technology that we're using, including cluster networks. But the way in which cluster networks work in Exchange DAG is they are very tightly integrated. When you add a mailbox server to a DAG, it's at that point where a cluster will interrogate the network interfaces, and whatever individual subnets cluster sees, it will bubble them up, and those will become DAG networks for you to manage. For those of you who are running 2010, in 2013, we eliminated the need to collapse DAG networks. So if you're used to doing that, you don't have to do that anymore in 2013 and 2016. Other than that, all network management after that point is done by Exchange. Exchange will go ahead and configure the appropriate flags on the cluster networks based on how you have configured the networks in the DAG. Now, typically in the DAG, we talk about two different kinds of networks. One being the MAPI network, which is the network on which MAPI clients connect and Active Directory's there. And then we've got one or more optional replicational networks, and that's dedicated to replication traffic only. No client traffic goes over that. And so as a result of those configurations, Exchange will stamp certain flags. You can see these cluster network settings here. Exchange will create them manually, so you don't need to manage your cluster networks. And in fact, you shouldn't be changing the client access settings on them unless you're creating a backup network or an iSCSI network or some other network that you want the DAG to ignore. And in that case, that's when you would set the DAG flag to ignore equals true. And in doing that, that tells Exchange that, yes, there's another network interface here, and the administrator has a purpose for it, but it's unrelated to Exchange. So tell the DAG not to manage that network. It won't be used for MAPI traffic. It won't be used for replication traffic. It'll just be a network path that has an IP address that Exchange will completely ignore. Now, how many of you have heard of a cluster heartbeat network? Okay, wow, that's a lot of you have heard of something that doesn't exist, okay? So there's no such thing as a cluster heartbeat network, and there never has been. And here's why. That's because in a cluster, all networks are heartbeated, okay? So when you hear this term, heartbeat network, it's not a real thing. It never existed. You won't find any documentation about it because it's not a thing. So clusters use heartbeats to figure out if the other members are alive. They transmit periodic pings over UDP, and those pings are either acknowledged or they're not. If they're not acknowledged, there is a threshold for the number of missed pings one member will tolerate before considering the other member to be down. There's also a delay, an acceptable delay in response to the pings that these members will tolerate before they will consider a peer member down. Okay, now, most of you will not have to manipulate any of these settings, namely the same subnet delay or cross subnet delay. Most likely, what you would have to manipulate is if you're in a site resilience environment and you've got a very flaky network, you probably want to do the cross subnet delay and cross subnet threshold. Obviously, single subnet is all the members on one subnet. Cross subnet is you've got multiple subnets for your DAG members. Now, it's basically the delay times the threshold works out to equal the amount of time it will take to detect a node failover. Okay? So you want to make sure that you're not increasing them too far such that you're now masking an actual network problem. So manipulating these settings is not a replacement for a flaky network adjustment. Okay? It may help you in some scenarios, and some customers have actually started using that way and given themselves very long delays and very long thresholds and dramatically increasing the amount of time it takes to detect failure, which of course recovery can't happen until failure is detected, so that could blow some SLAs out of the water if you're not careful. But you want to be careful not to adjust these too far away from the defaults because that will indicate that you do have some sort of network problem that you're trying to mask here. Just out of curiosity, how many of you have had to adjust these on your existing DAG? A few of you, okay. All right, let's talk about quorum. Okay, that's another clustering component. But it's actually two things when you think about it. There's the quorum itself, which would be considered the physical number of votes, and we'll talk about that. But then there's also this concept of quorum that is driven directly off the physical number of votes. So clusters require quorum in order to operate. A DAG requires quorum in order to mount database. If the underlying cluster doesn't have quorum, Exchange may be healthy and working fine, but it won't mount any databases without quorum. It's a protection mechanism to prevent split brain from occurring at the application layer. Okay. Now, a cluster, in order to maintain quorum, has to have a minimum number of votes. And it's a very easy calculation. It's the total number of votes divided by 2 plus 1. And you always want to have a whole number there. There's no fraction of a server or fraction of a vote. There's either a vote or 0 votes. And we'll talk about 0 votes as well. Now, historically, in order to achieve resiliency, what some previous Exchange customers would do, like in 2007, and some of you may have done this in 2010, is they will add additional servers that don't have user load in there just to get additional votes in the cluster. Why would you want to do that? Well, the more votes you have, the larger the cluster, or the larger the cluster, the more votes you have. And when you think about that, votes, again, the more votes that you have, the more that you can lose and still keep the system up and running. Okay? So the calculated votes are required for quorum. That is a majority base. You have to have a majority of the actual number of votes in order for quorum to be maintained. And if you don't, quorum is lost and the entire solution self-terminates. So what does it look like? So here's an asymmetrical data center deployment. Hopefully none of you are doing this because we want you to do symmetrical ones, and we'll talk about that in a minute. But I've got 2 data centers, and I've got 5 Exchange servers in my DAG. So how many votes do I have? Just shout it out if you know. Shout it out a little louder. 5, that's right. I've got 5 votes. Okay. So I need a majority of 5. Okay, so 5 divided by 2 plus 1 is, in whole numbers, the answer's up there in parentheses. 3, that's right. Okay, so we've got 3 votes over there, 2 over here. We lose the WAN link. Anytime the network is severed in any DAG, what happens to one half the DAG? It goes down. What happens to the other half? Stays up. That's right, because it's got the majority of votes. So it maintains quorum, and these databases then fail over there, and they're served by that data center. Same thing happens in a symmetrical DAG. I've got 3 members in each site, so a total of 6. That's an even number. I can't have an even number of votes because the calculation won't allow it. I need a tiebreaker, so I've got my witness there. The witness itself does not have a vote because the witness is not a member of the cluster, but when the witness is needed, it will pretend it has a vote by another node having 2 votes. Okay, when is the witness needed? Who knows? When what? Nope, not when there's a draw. There's a very specific, there's only one condition in which the witness is invoked. Only one condition. A little louder? No. The witness is invoked only when you're 1 vote away from losing quorum. That's when the witness vote kicks in. So, in this case, we need 4, a majority of 7. We lose the WAN. These 3 go down, so we lock the witness, giving it a vote, and now we still have votes, and that solution stays up. That's the only time that the witness is used by the cluster is when you're 1 vote away from losing quorum. All right, then of course the failure here means the databases fail over to there. Now, you can play with votes, okay? There's a node weight property. Windows gives you the ability to go and take votes away from cluster members if you want to. I'll show you why you would want to do that. But before I do, keep in mind that in an Exchange DAG, Exchange bases its quorum model, in other words, whether or not it uses a witness server, based on the number of members in the DAG. Okay? Exchange doesn't know anything about the cluster or votes or anything like that. So if you take a vote away from a DAG member, Exchange doesn't know that, and so the quorum model that Exchange configures will not match the model that you now need to use because you manually took votes away. So if you do go in and you take votes away from any of your nodes, be aware that you'll also now be responsible for manually going into the cluster tools and changing the quorum model to either use or not use a witness, depending on how your vote count changes. So keep that in mind. But we give you the ability to do that. Why would you want to do that? So that if you do have a data center that might be on the other side of a flaky network, the loss of that data center doesn't therefore result in the loss of votes, which means it doesn't affect the quorum calculation. So what I've done here in this example is I've manipulated the votes such that I've taken them away from these 2 and allowed those 2 to keep them. So because the total number of votes is now 2, I only need 1 vote in order to maintain quorum. Okay, so I can have that one go up and down. It doesn't affect the quorum calculation. I can have that one go up and down. It doesn't affect the quorum calculation. And further, because I only need 1 vote, I could also have one of those go down either unexpectedly or maybe I might take it down for maintenance and still not affect quorum and still be able to keep that last server up and running there as well. Now, tread very carefully if you're going to do this because it does increase your administrative burden. But there are potential upsides to removing votes away from DAG members. Now, just when you thought you understood that, along comes a new feature in 2012 R2 and later called dynamic quorum and dynamic witness. So a couple things about dynamic quorum. First, it works with most DAGs. We can't say all DAGs because we don't do any testing with any DAG that uses our third-party replication APIs. But I'm not aware of a single customer anywhere using that. So suffice it to say it works with all DAGs, but we can't say all. All of our internal testing has it enabled. It's all enabled in Office 365. Every DAG has it there. But again, it doesn't change the quorum requirements, and Exchange still doesn't become quorum aware as a result of it. So what is it? It allows the cluster to survive failures that previously would have resulted in the loss of quorum. Okay? The rules are fairly simple. If a node goes down, it loses its vote. When the node comes back up, it gets its vote back. And assuming quorum is maintained after one of these failures happens, then the system will recalculate the number of votes that are required and keep the system up and running longer and longer. So let me show you what I mean by that. So here's the rule. This can be triggered either from a shutdown. An admin can go and just shut down a node orderly, or it can be a failure. Power could fail, or the motherboard could die, or whatever. But a failure happens, okay? Dynamic quorum sees if quorum is maintained. If quorum is not maintained as a result of the failure, the cluster terminates. If quorum is maintained after the failure, then that recalculation occurs, and the votes that are now missing are removed from the calculation, therefore, thereby reducing the minimum number of votes that you need to keep the system up and running. And then it continues running all the way down to last man standing. So what does that look like? So I've got 7 votes here. Again, symmetrical data centers, 3 in each side, so each of them has 3 votes, and then my witness server has that 7th vote. So I need a majority of 7, which is what? How many votes do I need? 4, that's right. Okay, so failure happens. Okay, takes out that data center. I've got the majority over here, so they maintain quorum. They go down. So now what do I need? I've maintained quorum. A failure's happened, so now the recalculation can occur. Instead of a majority of 7, I need a majority of 4. Okay? What's a majority of 4? You don't sound very sure. It can't be half. We can't have a tiebreaker. It's got to be +1. It's 3. That's right. So I can lose 1 more, and I still have 3 votes, 2 from the servers and 1 I just got from locking the witness. So quorum is also maintained here. Okay? So we can recalculate. Now we need a majority of 3. What's a majority of 3? 2. That's right. Boom, I can lose another one. I need 2 votes. Do I have 2 votes? Yes. Okay, now I can recalculate. Now I need a majority of 2. What's a majority of 2? In this case, it is 1. Okay, you can go down to half, but only at this point. And what that means is I could lose one of the votes. It could be the witness, and I could have 2 servers standing up, or it could be one of the other votes. Now, what happens when you're down to the last 2? Dynamic quorum will take the vote away from one of those servers and leave one of the other servers with the vote. You won't know which one it was until you interrogate it, or until you do something silly like shut down the wrong one that has the vote. Okay? And then you're left with an Exchange server that now has no votes and comes down on its own. So we call this the last man standing in this scenario right here, or actually, no, yeah, that comes down. Okay, I guess I don't have the last man standing slide. Pretend he has a vote left. So think about this, though. You've now lost 5 out of 6 of your DAG members. Okay, is dynamic quorum going to really help you here? No, it's not, because that last server, there's no way it has been designed to handle the load that would be distributed across all these other servers. And we would never want you to do that. Don't ever over-provision the server to account for something like dynamic quorum. Okay. Now, you'll also want to check with getClusterNode which one has the vote and which one doesn't have the vote. Again, 1 means it has the vote, 0 means it doesn't have the vote. The only other thing I'll mention about dynamic quorum is you can tell if dynamic quorum takes it away by this dynamic wait property. The node wait property, again, that's the administrator manually taking a vote away. If admin takes the vote away, dynamic quorum never gives it back. Okay, so once the admin takes it away, that's a 0 at all times. Dynamic quorum won't do anything there. All right, and then of course, they added after that dynamic witness, which is largely the same exact behavior except now for the witness server. The witness server has failed or offline, the vote is removed. Or if you're down to that last man standing situation where you've got 1 server and the witness vote will be removed so that the server can stay up and retain it. You do have some control over it if you are familiar with your node IDs, because in dynamic witness, it will look to the node IDs and see if there's a lower one, and if there is, it will use the lowest node ID to take that away. You can also use this optional property right here. If you set that for servers in a distant data center, that will prevent them from getting the votes, and always keep your primary data center having the servers be the votes. All right. So our guidance on both of those from both the cluster team and the Exchange team is just leave them on. They're enabled by default. They're going to do their thing. but don't factor them into your availability or capacity planning or other sizing plans at all. They're just things that are there that may be able to provide you with greater resilience in some failure scenarios, but largely from an Exchange perspective, they are uninteresting because that last server, last couple servers simply won't be able to bear that load. All right, let's talk a little bit more about the witness server. The witness server, we now give you some new placement options. Okay, so you can do things like put it in a third data center or put it in Azure. That's another option that we have. By putting the witness server in a third location whose network is independent from the other two locations, especially from a failure perspective, you can then get automatic failover for your databases and therefore automatic data center site resilience as well. Okay, so let's talk a little bit about Azure. Azure does have some requirements associated with it. When we're talking about this, we're talking about the Azure Infrastructure as a Service platform. And basically, you're creating a file server and a directory server. You're replicating your internal AD to the directory server you're deploying in Azure. And then you're creating a separate file server that will act as the witness and configuring permissions and so forth. You'll also have DNS resolution, and you'll have multi-site VPN connectivity, VPN from each data center going up into Azure. ExpressRoute is currently not supported, so multi-site VPN is your only choice right here. This is largely what it would look like. You've got a DAG that's extended across a couple of your data centers, and then each of those data centers has a dedicated persistent VPN connection to Azure and is integrated with the Azure networks. And if you have any kind of a failure in either of these data centers, presumably the other data center should be able to lock the witness server that's up in Azure and achieve that automatic site failover in response to failure affecting one of the other data centers. So the high-level configuration steps, you got to do the Azure networking up front. Unless and until that's done, you won't be able to do anything like replicate your DC up there. Then configure your virtual machines. We do recommend using a separate DC and a separate file server. It is, however, supported to use just a single box that has both on it. But putting your witness server on a directory server is not something that we recommend. It is supported because there's some organizations who that's the only server they have available for their witness server. But we largely don't recommend it because doing that requires you to make the Exchange Trusted Subsystem a domain admin. And you probably don't want that universal security group being a domain admin. So you configure the two separate servers, then you'll configure 2016 to use the witness server the same way you configure it to use any witness server, and then validate and test it by initiating failover tests. All right, and speaking of DAGs and IIS, more recently we've also supported the ability to deploy DAGs within IaaS, okay? And that includes wholly going in, so your entire DAG is in that platform, or taking a DAG that's deployed on premises and extending it up into the cloud into an IaaS infrastructure. Okay, so a couple things I'll say about that. The first thing I'll say about that is that's not Exchange in the cloud when you do that. That's just Exchange running on VMs somewhere else, or maybe someone's co-hosted physical hardware. Also, the cost of goods for doing something like this is significantly more expensive than just going with Office 365, okay? So if you like the idea of Exchange running a cloud data center, Office 365 is awesome for you. But if you want to do it yourself, you need to make sure, first of all, that you meet all of our supportability guidelines. And so right away, that might be a deal breaker for some of you, because those guidelines mean your IaaS providers, if they're using virtualization that's not part of the SVVP and therefore not supported by Exchange, then that's not a supported implementation, so you won't be able to use that. So like as an example, Azure obviously is using Azure and the Hyper-V virtualization. Obviously, we support that, but there's still requirements there. We still need you to have premium storage for Azure for all of your Exchange databases and your log files and your transport database and so forth. That right there, just a moderately busy server using Azure Premium Storage continuously is going to be a lot more expensive than the least expensive mailbox you could buy in Exchange Online and Office 365. But it is possible, but again, you've got to meet the supportability requirements. Some customers are going to want to take their DAG and stretch it into IaaS just because they can. It will give you similar benefits to deploying to a second data center, except that you will have largely a lot less control over those bits than you would your own physical location. Sizing is going to be very important, especially for the network, because now we're constantly replicating to the cloud. It's not just the database and log traffic. Don't forget about things like AD traffic, DNS traffic, the witness pings, and of course, the search catalog as well. Content indexing also gets replicated to the other copies too. And then the design and sizing may be challenging because your provider might be limiting you on sizing of VMs, and you might not be able to create a VM that's large enough to support your needs as well. If you do want to do it, though, the entire preferred architecture can be implemented in that platform. And in fact, some of it is really almost required in that platform. Something like backup could be very, very difficult to do in an IaaS environment, and so that's one of the reasons you would use Exchange Native Data Protection. Many providers have multiple regions, so you could get the third data center scenario with your witness server if they have multiple regions, so that could be something that could be easy to do. So there are trade-offs back and forth depending on whether or not you want to do that. Out of curiosity, who here is interested in deploying a DAG in this manner? That's pretty much what I thought. All right. But we support it. All right. Finally, some miscellaneous stuff. There's a KB that all of you who are hopefully running on Windows 2012 R2 right now. If you're running 2012, that's okay, but I would strongly recommend getting up to 2012 R2, especially if you're going to deploy Exchange 2016. But there is a 2012 counterpart to this KB, but this KB tracks all of the recommended hotfixes that Windows clustering comes out with. And generally, all of those recommended hotfixes, we also want you to deploy on your Exchange DAGs as well. And in terms of deploying hotfixes and patches, that's very difficult to automate. I have yet to run into a single customer who's been successful in automating patching of their DAGs, simply because of the different scripts that need to be run and all the other work that has to go into it as well. Maintenance is a little bit more complicated in 2013 and 2016, especially when you consider something like 2016 that now has all the roles on it. So you're not just doing maintenance on a DAG member. You've got a box that has a transport queue, so you've got to drain that queue now. You've got a box that maybe has active calls, so you've got to quiesce those calls and so forth. So it's a lot more involved when you're doing maintenance. For one thing, we introduced this new thing called maintenance mode in 2013, and we carried it forward into 2016. Now, in 2010, we did have these DAG server maintenance scripts, start DAG server maintenance and stop DAG server maintenance. Those are designed and should only be used on Exchange 2010 DAG members. Even though we shipped them in the box in 2013 and 2016, those are for backward compatibility purposes only. They should only be used on a 2010 DAG. They're not to be used, and they're in fact not supported on 2013 or 2016 DAGs. But we haven't done a good job about making that clear, so I wanted to mention that. So we don't have any scripts that allow you to put a DAG server into maintenance. What we do have is on TechNet, all of these high-level steps, we have the one-liners that you would execute to do them. So you could copy and paste them all into your own script and do all these things to get the server ready for maintenance. So doing things like blocking the server from activation, failing over all the databases that are on that box, stopping transport from accepting new connections while you're draining the queue, maybe even forklifting messages over to another server to get that queue drained like that, and quiescing calls and things like that. And then there's that feature called Managed Availability that has that response capability. It can take action if it sees things. You'll also need to turn that off as well so that it doesn't do something like reboot the server while you're trying to do something on it. And then I always like to also confirm these things before I actually do the actual maintenance on it. So it's one thing to initiate the command to drain the queue, but it's another thing to actually have an empty queue. So the fact that you've said, OK, drain the queue, doesn't mean the queue's empty. So I always like to go and empty the queue and make sure that the calls aren't in progress before I do that. And then once you're done with the maintenance, you basically undo these things, take the server out of maintenance mode, and once you unblock it, you can rebalance the DAG and move databases over to it. Now, in terms of activation blocks, historically, we've had two primary ways for you to do blocking. One is at the database level, which is the first one, the activation only parameter, and then one is at the database or at the server level. So you can take an entire server and say, don't activate anything on this server at all. One of the new things that we've done is we've given you this new parameter for set mailbox server, this database copy activation disabled and move now. That is specifically for site resilience, and namely for site activations. This is the fastest way that we have for you to get databases off of a server and prepare for moving activity over to another site. And it will also mark the server as blocked from activation, so as these possibly multiple servers in parallel are moving databases over to another site, it'll prevent databases from coming back to the site you're trying to move off of as well. One thing it won't do, though, is if you do have activation blocks set on any of your servers, we won't move databases to a server that you've explicitly blocked. So it's a new setting. We introduced it late in 2013, and of course, it's in 2016 as well. And like I said, it's primarily designed to be the fastest way to get databases off the box. And it's basically a continuous move attempt. So the server can remain in service, actively servicing clients or doing whatever you need it to do. All the while, we're trying to move active service off of that box. And then once we've done that, then the server's just in a completely passive state at that point. All right. Lastly, let's talk about some site resilience best practices. And I would hope that I'm preaching to the choir here, but I do find, based on some of the support calls that we get, that not every administrator is actually exercising their site resilience or their disaster recovery logic or steps and whatnot. And that's actually something very important, because that's a lesson we learned ourselves at Microsoft after doing it over and over and over again, is you get better at it each time. And the first time you do it, it's just a disaster. It takes, way longer than you'd ever expect, and things never go the way you'd expect, and you're always forgetting something, and people don't follow the right processes. But then over time, if you continuously test and document and keep doing these things, you get better and better and better at it, so much so that it almost becomes almost like a reflex, like memory muscle. And that's the most important thing. You want to just do these things without hesitating. Because from a recovery standpoint, really humans are the biggest barrier to recovery, because we're stuck trying to analyze or solve the problem we just learned about instead of doing what the system we've built is designed to do, which is just push the button and do the activation. Okay, so really that would be the best advice, is don't get stalled in whatever the failure is or whatever the fix is or how long it's going to take or whatever. You've designed a highly available and site resilient system to recover from these failures. So when failure happens, there should be no hesitation. You should invoke your recovery logic, or better yet, take advantage of the features in Exchange that now let you do that automatically. All right. So with that, that actually ends the Exchange track. So there's no more Exchange sessions, I know. I have a sad. But there'll be more next year, don't worry. But I will be at happy hour later, and I also intentionally, because I wasn't sure what content you wanted for this session, I also did leave a few extra minutes for questions at the end, too. So, who has questions? And all your heads are hurting. It's all the quorum talk. It happens every time. Yes, sir. Say that a little louder. Is there any difference in maintenance with lag databases? What kind of maintenance are you referring to? Sure, so a lag copy isn't a highly available copy. It's a passive copy that's behind in time, so there's really nothing for you to do when you're putting a server in maintenance. As far as the database copies go, the only thing from a maintenance standpoint that you're concerned about is making sure there's no active copies on the server, because it's going to be going up and down, and then blocking the server so it can't be a candidate for activation. So if something happens on another server, you don't get an active copy suddenly showing up there. But from a lag copies perspective, there's nothing special that you need to do for server maintenance. Yes?
What's the
Great. What's the requirement for having the directory server if you're going to have the Azure Witness? The requirement is the security model that we use. So the Exchange Trusted Subsystem has to be a member of the local administrator group on your Witness server in order for it to do things like create the directory and share it out and allow cluster to do the pinging. And so without a directory server there locally, we've got no way for that Witness server to authenticate the trusted subsystem. Yes, sir.
In the scenario with the witness and the third day separate, you've got two bases and different sites.
Mm-hmm.
What if there's a routing problem between the two sites? So both sites can still access the witness?
Great question. What if there's a routing problem between the two sites so that both sites can still access the witness, but they can't talk to each other? So that's when the race happens. And the race is stacked against all of the nodes that don't have the cluster core resource group. So when you create a cluster, it creates that core resource group. In the dynamic quorum slide, that was the core resource group I was showing with the IP addresses and network names. When you don't have the admin access point, the core resource group is just the file share witness. If you don't have the file share witness, that group still exists even though it's empty. So that group is owned by one node at any given time. And when you have a failure of a cluster or a DAG, again, half of it's going down, half of it's staying up. The half that stays up is going to be the half that gets to lock the witness server. The node that owns the default cluster resources gets a 6-second head start to lock the witness server over every other node. So it goes first, and assuming it can communicate with the witness server, it will lock it. Now, if enough nodes, and we call that the locking node, and it's the locking node that gets that second vote for the witness. So if we have enough members that are in communication with the locking node such that they can maintain quorum, they'll stay up. The other members that can't communicate with the locking node will go down because they'll lose quorum. So it's not a transitive thing. The fact that they can both talk to the witness doesn't matter. They have to talk to each other in order to maintain quorum. Make sense? All right. Yeah.
When you've got dynamic quorum stuff turned on,
Mm-hmm.
and you lose, for your example, the 3 servers on the right,
Mm-hmm.
just 3 plus minutes.
Mm-hmm.
Once it's renegotiated with dynamic quorum mapping, 3 plus 1.
Mm-hmm.
Does it drop with one, or drop a lock on the server and go back to quorum of majority of 3, or does it use the witness server?
So at that point, once quorum has been recalculated, the lock will be released by the witness server, assuming you're more than one vote away from losing quorum. If you're back down to the scenario I had, where we're always basically one vote away, then the lock will persist on the witness. So that's, again, that's the only time the witness is actually used, when you're one vote away from losing quorum. That's the sole purpose of the witness, is to give you that one last vote to save you. Yes? Why is premium storage required? That's a great question, because we need IOPS. We have reduced IOPS significantly in Exchange, but the IOPS you get from Azure Standard Storage aren't enough to operate almost even a test Exchange server. If you try to do it yourself, it's a very slow and painful process on standard storage. So we said, forget it. No one's ever going to be successful doing this. We'll have to go for premium. All right, yeah.
When you say directly with architecture that multiple databases per volume, does that mean different databases, or is it making copies of the same database?
So you're talking about multiple databases per volume? So typically the way that works, so you're wondering what's on that volume. So in the preferred architecture, we want a symmetry where we've got the number of databases per volume equal to the number of copies per database that you have. So we want you to have 4 copies of each database in the preferred architecture. Therefore, we want you to have 4 databases per volume. But these are 4 different databases. You've got an active copy of one database, 2 passive copies of 2 different databases, and then a lag copy, which is the point-in-time backup of yet a 4th database. So these would all be separate databases and different copies of each of the separate databases. What's the reason for?
What's the reason for
Oh, well, simple. It's all about reseeding. When we came upon this architecture, multiple databases per volume was created in 2013 because 2013, we sort of looking at the crystal ball when we're designing applications like this because we know they're going to live for years. So when we were designing 2013, we actually specifically optimized for 8 terabyte hard drives. But of course, at that time, 8 terabyte drives weren't even available. But we still wanted to optimize for them. And now we have this challenge because we have our maximum recommended database size, even in a replicated environment, is 2 terabytes. So if you're deploying on an 8 terabyte disk, you have this choice that you would have had to make, which was increase the database beyond 2 terabytes, which is a bad idea, especially from a reseed standpoint, or waste 6 terabytes of space on that new hard drive that you just bought. So we didn't want that to happen. So instead, we optimized Exchange. We did a lot of work in 2013 to get a 50% reduction in IOPS so that we could very comfortably operate multiple databases on the same single disk without choking one of them out. So if we have an active and, say, 3 passive copies, the IOPS that we get from today's SAS and SATA disks, we get more than enough to account for that activity. So now, you don't have to make that choice anymore. You can fill up that 8 terabytes, but you're doing it potentially with 4 2-terabyte databases instead of one large 8 terabyte database. And with the auto reseed capabilities, when you've got multiple databases on that single volume, we automatically will reseed from multiple sources, unlike a single database paradigm where we're only seeding from a single source. So we're source bound. So when you think of something like 8 terabyte database coming from a single source, that could take something like 93 hours just to reseed that. That's operationally untenable. But if you have 8 terabytes of data, but it's broken down into 4 2-terabyte chunks, and you're reseeding from 4 sources instead of 1, now your reseed of that 8 terabytes takes about 32 hours instead of 93, and it gets all of your databases back right away. So it was a combination of things, the size factor, the reseed factor, and so forth. All right. How are we doing? All right, we've got about 1 more minute left. All right, well, if you can't think of anything now, feel free to email me after the event, schnall@microsoft.com. And with that, thank you very much for coming.